Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 21st, 2025, about 5 days ago. This paper proposes a fascinating mechanism for how LLMs learn on the fly, showing how a transformer block can implicitly modify its own weights based on the examples you provide in the prompt. The paper is titled, Learning Without Training: The Implicit Dynamics of In-Context Learning. And the authors provide a really compelling mathematical explanation for this effect. They show this process isn't limited to simple models and even resembles a form of gradient descent, all without explicit training. Alright, so to test this theory, the authors ran an experiment, and these first plots show the results. We're looking at loss curves, and loss is just a measure of the model's error, so lower is better. The key thing here is that they compare two ways of calculating the error on new data. The first is the standard way, where the model sees the examples in the prompt. The second uses their theory. It takes the examples away and instead applies that implicit weight update. And as you can see, especially in the close-up on the right, the two resulting loss curves are almost perfectly identical. So, if the model is implicitly updating its weights, what does that process look like over time? Well, this next plot shows exactly that. On the horizontal axis is the context length, basically how many examples the model sees. The vertical axis measures how much that implicit weight update changes with each new example. And as you can see, the change drops off very quickly, approaching zero. This is called convergence. It shows the learning process is stable. The model learns what it needs from the context, and then the updates effectively stop. So the natural next question is, how does this implicit learning compare to actual training? This plot directly compares the two. The blue line, labeled delta W, represents the implicit update we've been discussing. The green line is for gradient descent, which is the standard mathematical process used to train models by repeatedly adjusting their internal settings to reduce errors. As you can see, both methods lower the model's error in a remarkably similar way. This suggests that in context, learning isn't just a party trick, it's a genuine learning dynamic that closely mirrors explicit fine-tuning. So what's the big picture here? Well, the key takeaway is that in context, learning the model's ability to learn from examples in a prompt isn't some kind of magic. It's a direct result of the transformer architecture. The self-attention layer interacts with the multi-layer perceptron, a core part of the network, to create a low-rank update. This is essentially a very efficient, targeted change to the model's settings that looks a lot like actual training. It's an elegant explanation for this powerful LLM ability. That's all for today. Thanks for tuning in.